Hi, in this video, I will be showing you problem number 24 of chapter 15, section 1. Evaluate the iterated integral 0 to 3, integral 0 through 1, 7xy, square root of x square plus y square, dy dx. So notice that it is an iterated integral, so double integral. And you also notice that the inner integral is with respect to y. So the inner limits are from for the variable y 0 to 1. The outer integral is with respect to x. So the limits for x are from 0 to 3. So let's write down the step 1, just writing the integral I, the given integral as I. So notice here 7 is a constant. So 7 can be pulled out of the integral sign. So it's 7 times integral 0 to 3, integral 0 to 1, xy times square root of x square plus y square dy dx. Then I is 7 integral 0 to 3, and x can be taken out because the inner integral is only with respect to y. So x can be taken out of that inner integral, but still within the integral for x. So we'll keep x inside the integral for the first integral. For the inner integral, as it is integral with respect to y, x can be treated as a constant, so that is taken out of the inner integral. So it's integral 0 to 1, y times integral square root of x square plus y square dy. Then outer integral is dx. So let us consider the inner integral and call it I1. We will separately evaluate that I1. This is our step number 1. This I can be named as 1. So step 2 is to evaluate the inner integral I1, which is integral with respect to y, keeping x as a constant. So integral 0 to 1, y times square root of x square plus y square dy. We can evaluate this keeping in mind that this is integral with respect to the variable y. So x is treated as a constant. X or any function of x or any exponent of x is treated as a constant. So we are going to do this integral by u sub method, substitution. So x square plus y square equal to u. That will mean 2y dy equal to du because x is treated as a constant. So derivative of a constant is 0. So derivative of x square would become 0. So 2y dy equal to du. So this will mean integral I1 is integral square root of u du over 2. This will be 1 half u to the power 3 by 2 over 3 by 2. You will get 1/3 x square plus y square to the power 3 by 2. But this has to be evaluated between the limits 0 and 1. So the limits are only for y, so keep in mind. So you are going to plug in only for the variable y. So it will be 1/3 x square plus 1 to the power 3 by 2 minus x squared to the power 3 by 2. That will be x cube. Everything is inside the parentheses and 1/3 lies outside. This is the value of inner integral I1. Now we are going to get back to this step, step number 1, and we are going to plug in this value of I1 into the step number 1 for I. So substitute A, which is the value of I1, into the integral expression for I in step 1. So we have I equal to 7 stays outside still. So 7 times integral 0 to 3 x 1/3 by substituting for I1, get 1/3 x square plus 1 to the power 3 by 2 minus x cube dx. The 1/3 can be taken out, so it is 7 over 3, integral 0 to 3, x times, now you distribute the x for both the terms, x times x squared plus 1 to the power 3 by 2. So we are distributing that x times x squared plus 1 to the power 3 by 2 minus x to the power 4 dx. For all of this, 7 over 3 lies outside this integral. And now we are going to evaluate this I2, which is integral 0 to 3x times x squared plus 1 to the power 3 by 2 separately. Integral of this one is simple, which is integral x to the power 4 is x to the power 5 over 5. We will fill in that information later. So the next step that we are going to do, which is step number 3, is to evaluate the integral I2, which is integral 0 to 3 x times x squared plus 1 to the power 3 by 2 dx. Again, this is done by u sub method. So x squared plus 1 equal to u, 2x dx equal to du. So I2 will become u to the power 3 by 2 du over 2, which is the value of x dx, which is 1 half u to the power 5 by 2 over 5 by 2. U is x squared plus 1. So it is x squared plus 1 to the power 5 by 2 over 5 by 2. So flipping the 5 by 2 and cancelling out the 2, you get 1/5 x squared plus 1 to the power 5 by 2 between the limits 0 and 3. So it is 1/5. So if you plug in x equal to 3, you get x equal to 3, you get 10 to the power 5 by 2 minus 1. So this is the value of I2, and this is going to get back to this step. So we're going to plug it in over here in I2. So step 4 is to substitute the expression for I2 into I. Substitute I2 into I in step number 2, we get I equal to the given integral equal to 7 over 3. Then we are substituting for I2, which is 1/5 times 10 to the power 5 by 2 minus 1, which is taken from here in this step, minus x to the power 5 over 5, because that is the integral of this x to the power 4 between the limits 0 and 3. So it is 7 over 3 times 1/5 10 to the power 5 by 2 minus 1 minus plug in 3 for x, that will become 3 to the power 5, which will be 243 over 5. Here 1/5 can be taken out, so it is 7 over 15 or 3 times 5, 10 to the power 5 by 2 minus 1 minus 243. So this will become 7 over 15, 10 to the power 5 by 2 minus 244. Now in these two terms, we notice we can actually play with this 10 to the power 5 by 2 and write that as 10 to the power 1 times 10 to the power 3 by 2. So 1 plus 3 by 2 will become 5 by 2. It's 7 over 15, 10 times 10 to the power 3 by 2 minus 2 times 122. The reason for writing 244 as 2 times 122 is we are going to common factor the 2 from the first term and the second term inside the parentheses. So it is 7 times 2 over 15. 5 times, if I take the 2 out, I'll get 5 times 10 to the power 3 by 2 minus 122. So I will have 14 over 15. 5 times 10 to the power 3 by 2 minus 122. That is the value of I. Hope this video helps.